What's up, amazing people, students, lovers of chemistry, and each and every one of you who subscribe to my YouTube channel. I'm super excited to be here with you on today's episode, which happens to be the fifth part of this series on naming organic compounds that we have been on thus far. And today we have something very special that we want to look at. We want to look at the concept of special cases in naming organic compounds. We want to look at the concept of naming cyclic compounds and so much more. So without wasting time, let's get into what we have for today's video. So to start off this video, let's start by defining what a cyclic compound is. So basically, what's a cyclic compound? A cyclic compound is simply the combination of two words, cyclic and compound. So putting the two of them together, a cyclic compound is a compound where the carbon atoms are joined in a ring or a cycle format. Okay, now if you checked very well, the previous videos that we've been treating on this series, we've only been dealing with compounds that were in a straight chain format. We have carbon bonded to another carbon, bonded to another carbon, bonded to another carbon. Maybe there's a branch at one point or the other, but we never dealt with concepts where we had something moving in a loop-like structure. So that's what we want to look at in today's video. That's why we're defining what a cyclic compound is. Okay, so it's a compound where the carbon atoms are joined in a ring or cycle structure. Now think of it like hands that are being held in a circle. All the carbon atoms connect to each other in a loop instead of a straight line. Now here is a very good example of what we have on the screen right now. This describes what a cyclic compound is. You can see the carbon atoms, they are being joined to each other in a cycle or ring format. It's more like going round in a cycle, and it has no end. So there are compounds that actually take on this structure, and compounds that do are called cyclic compounds. We want to see how to name them, and we want to see some other complex examples in naming organic compounds. I'm sure you're going to enjoy every bit of what we have in today's video. So now that we have defined what cyclic compounds are, let's move on to the next thing that we have in this video. And the next thing that we have in this video is how to name cyclic or cyclo compounds, whichever one you use. Now, to name a cyclic compound, the first thing you are to do is to use the prefix cyclo. Now, this word cyclo simply shows that it is in a ring format or ring structure. So once you have used the prefix cyclo, the next thing you are to do is to use the name that denotes the number of carbon atoms that are present. And we dealt with that in one of the previous videos. If you have 3 carbon atoms, you use the suffix prop. If you have 4 carbon atoms, you use the name but, and so on and so forth. So you count the number of carbon atoms that are present in the ring to determine the base name. Now, look at this example that I have on the right side of the screen right here. All the points where lines meet together are points where we have carbon atoms. So we have a carbon atom here, we have another one here, we have another one here, we have one here, and we have one here. That is why if I'm to redraw this structure, it will look something like this. This is what it will look like, and then we'll have hydrogens bonded to each carbon atom. So this is what this structure would look like if I am to draw it in a way that will be more simpler and more illustrative for you. So now that we have drawn this structure, if we want to name it, the first thing we have to do is to use the prefix cyclo. So now that we have the prefix in place, what are we going to add? We're going to count the number of carbon atoms. Now we can start from any point since we do not have a branch and since we do not have any assigned point of beginning. So we can start from any points. Let's start from here. 1, 2, 3, 4, 5 carbon atoms. 5 carbon atoms tells us that we use the suffix pent. And since it is an alkane, because only single bonds are present throughout the structure, we use the final suffix ane. So adding everything together, we have cyclo plus pent plus ane. The name then becomes cyclopentane. I'm sure you saw how the name was assigned. So now that we have named the first structure, let's go over to name the second structure over here. So we use the same format by starting with the prefix cyclo, and then we add name that denotes the number of carbon atoms we have. We have one carbon atom over here. We have 2, 3, 4, 5, and 6. 6 carbon atoms has the name hex. And since it is an alkene, because only single bonds are present throughout the structure, we use the suffix ane. So we have cyclo plus hex plus ane. That gives us the complete name cyclohexane. So that's how you name cyclo compounds. So now that we have dealt with those two, let's proceed into something that we'll find very important. Now, here is a rundown of the names that you are to assign to specified number of carbon atoms that are present in a cyclo compound. If you have 3 carbon atoms in a cyclo compound, you use the name cyclopropane, and 3 carbon atoms would look like this. Since it is a ring structure, it will look something like this. Some use the structure of a triangle. If you have 4 carbon atoms, it will look something like this, more like a square. Okay, and then of course hydrogen atoms will be bonded to all of the carbon atoms. Hydrogen atoms will be bonded to all of the carbon atoms. Some people actually draw it like this: CH2 bonded to CH2, bonded to another CH2, bonded to CH2. Whichever way you choose to draw it, it's fine. We use the name cyclobutane. When you have 5 carbon atoms, you use the name cyclopentane. And when you have 6 carbon atoms, you use the name cyclohexane, and so on and so forth. So now that we have that done and treated, here is one example on the screen right now. We had to name this compound. Now, for the sake of emphasis and for the sake of being as illustrative as possible, I have redrawn this structure to become like this so that you can see what's going on over here. Now, the first thing we are to do, as we have seen the rules previously for naming cyclo compounds, is to first of all have the prefix cyclo. So now that we have the prefix in place, we are to add the name that denotes the number of carbon atoms that are present. We have one carbon atom here, another one here, another one here, another one here, and one other one here. Let's count the number of carbon atoms. 1, 2, 3, 4, 5. Since we do not have any branch, we can start from any point, since it is a cyclo compound. So 5 carbon atoms tells us that we use the parent name PENT, and since it is an alkane, we add the suffix ANE. So altogether we have cyclo plus pent plus ANE, which gives us the full name cyclopentane. So that's the name of this compound as we have illustrated on the screen right now. So having named that, let's proceed to the next thing that we have. We have another example over here. Now, this example shows us that we have a branch, not just a cyclic compound. We have a branch over here. So what do we do? First of all, we have our prefix, which is cyclo. Now, how many carbon atoms do we have? 1, 2, 3, 4, 5, 6. We have 6 carbon atoms. That tells us that we use the name hex. And since it is an alkane, we have hex plus ane, which is hexane. Now, look at this branch over here. The branch is CH3, and CH3 has the name methyl. Okay, so since it is a branch, it now becomes the prefix, the original prefix that we use in naming it. So the prefix here is methyl, which is the branch. We have methyl plus the parent name of this compound, which is cyclo, plus the number of carbons that we have, which is hex, and then since it is an alkane, we use the complete suffix ane. So altogether we have methyl cyclohexane as the name of this compound. I'm sure you're seeing how these things are playing out, and if you're enjoying this video, please do well to like, share, and subscribe. All right, now having seen how to name cyclo compounds, let's move on to the concept of naming compounds with functional groups. Now this happens to be a personal favorite of mine, so let's define what functional groups are. Functional groups are simply specific groups of atoms that give compounds special properties. Okay, so now let's think of them like the personality of an organic molecule. Now, just like you have different types of human beings, you have those that are easily angry, those that are lazy, those that are hardworking, those that are, playful and fun to be around. In that same way, we have different organic compounds with different personalities. Now, that personality can be referred to as the functional group of the organic compounds because there are special atoms that are giving it that behavior. Those atoms are called functional groups. Now, let's move on to more concepts that will make that easy for us to grasp. Now, here are a few common functional groups that we have as far as naming organic compounds are concerned. Number one, we have the alcohol functional group. Now, the name of this alcohol functional group is called hydroxyl. And a very good example of a compound that has this functional group is ethanol. Ethanol is one of the basic alcohols we have in chemistry. And when we have this alcohol functional group, the suffix that we use is ol, all. That is the ending part of the name of a compound that contains alcohol. And the symbol that denotes it is OH. Now we have the next one, which is an acid functional group. Okay, now when you see the symbol COOH, it has the group name carboxyl, and the suffix that ends the name of a compound that contains it is oic acid. Okay, and a very good example of a compound that contains it is butanoic acid. Now don't get confused, we're going to be getting into examples that denote each and every one of these things. Okay, so sit back, relax, and enjoy every bit of this. And the symbol that denotes its presence is COOH. Next example of a functional group we have is this one that has the symbol CHO, and the name is called an aldehyde. Okay, the group name of this functional group is called aldehyde, and the suffix that ends the name of a compound that contains it is al, al. And a good example of a compound that contains it is methanol. Okay, the next one is called amine, and the symbol is NH2. A good example of a compound that contains it is ethanamine, and the group name is called amino, and it ends in the name amine or amine, whichever way you choose to call it. And then finally, we have this functional group called the ketone functional group. One example of a compound that contains it is propanone. I'm going to be showing you all of this, okay, so do not worry. And the group name is called ketone, and the end of the name of a compound that contains it is one, not one, it is called on. So now that we've talked about some of the common functional groups that we have, let's see the steps for naming them, and then we'll get into some examples. When you want to name a compound that contains a functional group, number one, identify the longest chain. I cannot stress the importance of this enough. You need to identify the longest chain. That will give you the name or the base name of that compound. Now you need to note that when you are identifying the longest chain, that chain has to contain the functional group. I'll show you in the following examples that we have. And then the next thing you need to do is to identify the functional group. And then finally, you choose the correct suffix based on the group that you have. All right, so now that that has been done, let's get into some examples. Example number one, we have this structure on the screen right here. So for the sake of being very illustrative, let me redraw it in a way that you can see each atom present. So we have carbon bonded to 3 hydrogen atoms, which is bonded to another carbon that has 2 hydrogen atoms, which is bonded to an OH functional group. So first things first, let's identify the number of carbon atoms. We have 1 carbon atom here and 2 carbon atoms here. So 2 carbon atoms tells us that it has the base name of ETH. Now, are we counting from the left to the right, or are we counting from the right to the left? Remember, we have a functional group, which is this guy over here. So we need to count from the end that is closest to the functional group. That tells us that we're counting from the right, number 1, to the left, number 2. So now that we have counted from the right to the left, this is an OH functional group. And OH functional group is an alcohol functional group. And the suffix that is used is OL. So we have ethanol as the name of this compound because there are 2 carbon atoms which has the base name ETH, and then we have OH as the functional group. So that tells us that it is ethanol. And since it is an alkane, single bonds are the ones that are present throughout the structure. We have ETH plus AN, which shows that it's an alkane, and then plus OL, which is the functional group. That's why we have ethanol as the name of this compound. I'm sure you're enjoying every bit of this lesson. Now that we have talked about naming organic compounds that contain functional group, let's talk about the priority order of functional groups. Now, when a compound has more than 1 functional group, the one with the higher priority determines the suffix, and the others are treated as prefixes. Now, I have some pictures and illustration on the screen right now of chickens, and that's because it's something that I can relate to. I once reared chickens in my house. Okay, now one behavioral pattern of chickens that I've seen that I love so much is the pecking order. There's something that we call the pecking order. Okay, when you're rearing birds, especially chickens. And what is that pecking order? It shows the level of authority or priority that each one member of the flock has. So for instance, now let's say you have more than 1 male chicken in a flock of birds. Now what will happen is after a while, one of them will assume a position of authority over the other ones. Now that one that assumes a position of authority will now be called the alpha male. Now what happens is that alpha male takes authority over the rest of the flock. He determines who can join the family to eat. He determines who can join them to sleep in their cage or whatever house it is that they are staying. And he's the only one that will have access to all the females in the flock of birds. The other ones now will be treated as sub males. Now I just brought that to be able to explain the concept of functional groups. Now there are times in organic molecules where you have more than 1 functional group. What do? One of them becomes the alpha male or the one with the higher priority, and the other ones now becomes the ones that will be treated as prefixes. Now let's see some examples to determine this. First of all, before we see examples, let's see the priority order or the priority list. Now, this is the list of priority of functional groups as far as naming organic compounds are concerned. The first on the list is carboxylic acid. Okay, there is no functional group that is higher than this guy right here when it comes to naming organic compounds. The next is the aldehyde. Okay, and of course, when you're naming a compound that contains an aldehyde functional group, you use the suffix Al. And if there is a carboxylic acid functional group and an aldehyde functional group, it means that this guy over here will become the prefix, while this one will become the suffix because this one is higher than this other one. And the next on the list is the ketone. The next is the alcohol, amine, alkene, alkyne, and then we have the alkyl or halogen functional groups. So now that we have seen the priority order from the highest to the lowest, let's deal with some examples. Before we deal with some examples, there's something else that I want you to understand. There are times that the functional group is treated as a prefix and not as the main functional group. Remember, I told you that when we have more than one functional group in an organic compound, one of them takes priority and the other ones submit to it. Now, when a compound has multiple functional groups, only one will be used as the suffix based on its priority. All other functional groups are treated as prefixes using modified names. What are those modified names? Let's check them out. So we have the first example. When we have an aldehyde, CHO, that is not the main functional group, we call it formyl. But when it is the main functional group, we use the suffix AL. Now, here is an example on the screen right now. We have COOH, and then it is bonded to CH2, bonded to CH, which now carries a functional group. And then it is bonded to CH3. This structure that I just drew here is the same thing as this one. Okay, I just chose to be more illustrative so you can see each atom in the compound. So now, how do you name this compound? First of all, you need to count the number of carbon atoms that are present. And to do that, let's do that very quickly. We have 1, 2, 3, 4 carbon atoms. 4 carbon atoms tells us that we have the name BUT. All right, so now that we have that name BUT, let's keep it aside because there are other things to take care of. Now, if you look very well, we have not one functional group, we have 2. There is one functional group over here, COOH, and then there is another functional group over here, CHO. Now, in the order of priority, COOH comes before CHO. So that means this guy over here is going to be the suffix, while this one is going to be treated as the prefix. So if we're going to treat this guy as the prefix, it means that we're going to use the name formyl. So now, if this guy is going to be given priority, it means we're going to count from the end that is closest to him. That is why we're starting our counting from the left to the right. So we have 1, 2, 3, and 4 carbon atoms. So that tells us that this guy over here now becomes a branch since he's not the main functional group. So we have this functional group on carbon number 3. So that gives us 3 formyl plus the number of carbon atoms that we have, which is BUT, right? And then plus the class that it belongs to. It is an alkene because, as you can see, only single bonds are present between all the carbon atoms in the compound. So we have AN, and then we have the last one, which is the suffix oic acid. So when we add everything together, we have 3 formyl butanoic acid. 3 formyl butanoic acid. That's why we have this final name over here. The main functional group is this carboxyl acid over here. That's why we use the suffix oic acid. And then aldehyde was treated as a prefix. That's why we have 3 formyl. I'm sure you saw how this was named. Let's treat another example. The next example that we have when a functional group is not the main one is the example of the ketone. Okay? And a ketone is simply a carbon atom that has a double bond to an oxygen atom. So now, when a ketone is the main functional group, we use the suffix ONE, on. All right? But when it is not the main functional group, we use the prefix OXO, oxo. So now we have this compound over here. So let's redraw it in a way that you can understand. We have CH3 bonded to C which is bonded to an oxygen atom. Don't mind this part, okay? This part is not part of it. All right, so we have it bonded to CH2, bonded to another CH2, which is bonded to COOH. So first things first, let's identify the number of carbon atoms that we have. So we have 1, 2, 3, 4, 5 carbon atoms. 5 carbon atoms tells us that the base name we're using is PENT, penta, which shows that there are 5 carbon atoms present in the compound. Next thing to do is to identify the functional groups. We have one functional group over here, and we have another functional group over here. So the next thing to do is, which one has priority? Of course, this guy has priority over this one. So we are going to give priority to this functional group, which means that we're going to start our counting from the right side to the left. And that also means that this guy is going to be the suffix, while this guy is going to be the prefix. So if we start our counting from right to the left, we have 1 carbon atom, 2 carbon atoms, 3, 4, 5. So if this guy is the suffix, that tells us that what we have is pentanoic acid as the parent name. Next thing to do is to identify the prefix. Now we have this over here as a functional group acting as the prefix. Now when carbon has a double bond to oxygen, it is called a ketone. But now it is acting as a prefix, so we use the name OXO, oxo, and it is on carbon number 4, which tells us that we have 4 oxo plus pentanoic acid. So altogether we have the complete name 4-oxo pentanoic acid. Remember, this functional group has a higher priority, so it takes the suffix oic acid, and then this ketone over here has a lesser priority, so it becomes the prefix. That's why we gave it 4-oxo. This 4 signifies that it is on carbon number 4 over here. And then pentanoic acid, penta here shows that we have 5 carbon atoms, and then the suffix oic acid shows that we have this functional group. I'm sure you're seeing how everything is playing out. All right, now that we have done that, let's see if we can check out yet another example. The next example that we have is the example of alcohols. Okay, now alcohols have the symbol OH. When they are the main functional groups, we use the suffix OL, but when they are not, we use the prefix hydroxy. Suffix means that they end the name, while prefix means that they begin the name. So we have this example over here. Let's draw the structure. We have CH3 bonded to CH, which has the OH functional group, bonded to COOH. So now, first things first, let's identify the number of carbon atoms that we have. To do that, we have 1 carbon atom, 2 carbon atoms, 3 carbon atoms. 3 carbon atoms tells us that we have the parent name PORP, prop. So now let's identify the functional groups. We have one over here, and we have another one over here. Since this one takes priority, it will now have the suffix propanoic acid. So now that we have identified the suffix to be propanoic acid, the next thing to do is to treat this one as a prefix, since it is not the main functional group. So now let's identify the position that it is on. Remember, since this is the main functional group, we are going to count from the end that is closest to it. So that means we'll count from right to the left. So we have carbon number 1, carbon number 2, carbon number 3. So automatically this hydroxyl functional group is on carbon number 2. So the prefix now becomes 2-hydroxy and then plus propanoic acid. So the complete name now becomes 2-hydroxy propanoic acid. I'm sure this lesson has been educative for you. If it is, please like, share to as many as you can, and subscribe because I enjoy relating with you guys on this space. Now, the next example that we have is the example of the amine functional group. The amine functional group has a symbol NH2. Now, when it is the main functional group, we use the suffix amine, but when it is not, we use the prefix amino. Now, here is one example on the screen. We have CH2 being bonded to an amine functional group, NH2. Then we have CH2 and COOH. So first things first, let's count the number of carbon atoms that we have. 1, 2, 3. 3 carbon atoms tells us that we have the parent name, prop. We have 2 functional groups, this one over here, which is the main functional group. So we use the suffix propanoic acid because the suffix is oic acid. All right. So now that means this guy over here will be treated as a prefix. And when we treat NH2 as a prefix, it has the name amino. So now it is on carbon number 3 because we're giving this one priority. So which means we're counting from the right to the left. So that means we have 3 amino plus propanoic acid. So altogether we have 3 amino propanoic acid. That's the name of this compound. COOH was treated as the suffix or was given priority. That's why we have oic acid. And then NH2 was treated as a prefix. That's why we have 3 amino. I'm sure you're seeing how each and every one of these questions are playing out. And then next thing we have are the groups called halogens. Now, when you deal with halogens, they are always treated as prefixes, okay? They are never used as suffixes. So, for example, you have names like chloro when you have chlorine, and you have bromo when you have bromine, Br, and then you have iodo when you have iodine. So we have this example on the screen, CH3 bonded to CH bonded to bromine, which is bonded to CH2 and then bonded to this alcohol functional group. So now the first thing we want to do is to identify the number of carbon atoms that we have. So we have 1, 2, 3 carbon atoms. 3 carbon atoms tells us that we have the parent name PORP. Next thing we want to do is to identify the functional groups. We have this functional group over here and we have another one over here. This one takes priority, so that means we are going to use the name AOL since it is an alcohol. So we have the name propanol as the parent name of this compound. Next thing to do is to treat this bromine as a prefix. So now let's do that very quickly. It is on carbon number 2 because we are counting from right to the left. So we have 2-bromo propanol. That is the name of this compound over here. I'm sure you're seeing how each and every one of these is playing out. And then finally, for functional groups, when they are not the main ones, we have the alkyl functional groups. This is where we have CH3, which is methyl, C2H5, which is ethyl, and so on and so forth. Remember, in one of the previous videos on this series, we said that alkyl groups are actually a derivative of alkanes, just that one hydrogen atom has been removed. So for example, let's say you have CH4. If you remove one hydrogen atom, it becomes CH3, and CH3 has the name methyl. So that's how we derive alkyl functional groups. And when they are in a compound, they are always treated as prefixes, okay? Their names are methyl, ethyl, propyl, butyl, and so on and so forth. And when you have more than one alkyl group in a compound, you alphabetize them with other substituents. So for example, let's say you have methyl, CH3, and you also have ethyl, C2H5 in a functional group. This one is called ethyl, and this one is called methyl. When you want to assign priority to functional groups or to substituents, you are going to give this one the higher priority because in the alphabetical order, it starts with the letter E, and E comes before the letter that starts methyl, which is M. So you're going to give priority to ethyl over methyl. So let's see if we can treat one or two examples under this concept, and then we'll proceed from there. Before we do, here is the summary table of all we've been saying for a while now. When you have the carboxylic acid functional group, you use the suffix oic acid. Okay, if it is a prefix which is not common, you use the name carboxy. When you have the aldehyde, and remember, carboxylic functional group has the symbol COOH. When you have the aldehyde functional group CHO, you use the suffix al if it is the main functional group. If it is not, then you call it formyl when you use it as a prefix. Then we have ketone, which is CO, and when it is the main functional group, you use the suffix one, on. And if it's not the main functional group, you use the prefix oxo, oxo. And now we have the alcohol functional group OH. When it is the main functional group, we use the suffix ol, all, and when it is not, we use the prefix hydroxy. We have amine, which is NH2. When it is the main functional group, we have amine as the name, and when it is not, we use the prefix amino. And then we have halogens. Halogens are chlorine, bromine, iodine, and so on and so forth. Now, you do not use halogens as a suffix when naming organic compounds because they are not treated as main functional groups. Okay, they are used as prefixes. You use chloro, bromo, iodo, and so on and so forth. And then finally you have alkyl groups. This is where you have methyl, ethyl, and so on and so forth. Okay, you do not use them as suffix either. You use them as prefixes: methyl, ethyl, and so on and so forth. So now here is a quick practice question. Can you name this compound? So let's see if we can do justice to this compound. Let's redraw the structure. So we have CH2 bonded to this functional group OH, and then we have another CH2, and then it is bonded to another functional group CHO. All right, now, so first thing to do is to count the number of carbon atoms that we have that will give us the parent name of this compound. So we have one carbon atom over here, two carbon atoms over here, three carbon atoms over here. Three carbon atoms tells us that we have the parent name PROP, prop. Next thing to do is to identify the functional groups. We have one functional group here, which is an aldehyde functional group, CHO. An aldehyde functional group is higher than this functional group, which is an alcohol functional group. So that means this guy now becomes the prefix, and this guy becomes the suffix. And when aldehydes are the suffix, we use the suffix al. So this now becomes propanal. So we have that base name in place. Let's keep it aside. So now let's deal with the prefix now. So we have OH bonded to CH2, bonded to CH2, which is bonded to CHO. Where are we going to start our counting from? Of course, at this point where we have our priority functional group. So we have 1, 2, 3. So this OH functional group is on carbon number 3. So we have 3 hydroxy as the prefix, because we're treating this guy as a prefix. And when alcohols are the prefix, we use the name hydroxy. If it was the suffix, we would have used the name ol, but now it's the prefix. So we have 3-hydroxy plus the base name, which is propanal. So all together now we have the name 3-hydroxy propanal. That's the name of this compound over here, 3-hydroxypropanol. I'm sure you're enjoying every bit of this lesson. If you are, one more time, I'm asking that the least you can do is to like, share, and subscribe to my YouTube channel so we can reach as many people as we can and do more good in the world. So now the next example that we have is this compound on the screen right now. So let's redraw it. We have CH3 bonded to CH, which has a functional group OH attached to it. And then we have CH2 bonded to COOH. So now this is the structure of the compound. The first thing we want to do is to identify the number of carbon atoms that we have. So to do that, let's determine if we're counting from left to right or from right to left. Now we have this priority functional group over here. So we're going to be counting from the end closest to it. So we have 1, 2, 3, 4 carbon atoms. 4 carbon atoms tells us that we have the name but, or but, whichever way you choose to call it. So now this is the priority functional group. That tells us that we're going to be using the suffix oic acid. So we have butanoic acid as the base name. So that means we're going to be treating this other functional group as a prefix. So to treat it as a prefix, it is on carbon number 3 and its prefix name is hydroxy. So we have 3-hydroxy plus butanoic acid. So altogether we have 3-hydroxy butanoic acid. That's the name of this compound over here. I'm sure you saw how it played out. So these are the steps that we took. It has both the OH and COOH functional group. Carboxylic acid is higher in priority, so it will end with the suffix oic acid. Alcohol now becomes hydroxy as a prefix. So the name now becomes 3-hydroxy butanoic acid. I'm sure you saw how it was named. So now here are some common errors that students make when they want to name organic compounds, and here are some tips on how to fix them. Mistake number 1 is not finding the longest chain. Now, what you need to understand is that there are times where students are counting the longest chain in an organic compound, and then they count in such a way that the chain they arrive at is shorter than what is possible as the longest chain. So you need to always count the longest continuous carbon chain. What you are to look for is continuity, not straightness. So you are not necessarily looking for the straightest. For example, let's say you have 1, 2, 3, 4, 5, 6, and then over here you have another one. And then they ask you to find the longest continuous chain. If you're looking for the straightest, you will go with this. Or if you're looking for the longest, you will go this way. So there are times students make this mistake by going for the straightest, not necessarily the most continuous. And when you're dealing with the longest continuous carbon chain, you are looking for the most continuous. All right. So the next mistake that students make is that they number in the wrong direction. When you are numbering, start numbering closest to the highest priority functional group or double or triple bond. You saw that in the examples that we treated. When we had a functional group like COOH, we made sure that we started numbering from the end that was closest to it. And then the next thing that students make as mistakes is that they forget the prefix. They forget the prefix, okay? When you have, for instance, more than one of the same substituent, let's say you have CH3 appearing more than once, appears more than one time. So let's say it appears 2 times. Instead of you to now say dimethyl, you just use the name methyl, which is very wrong. Okay, when you have more than one of the same substituents, use correct prefixes to identify their presence. And then finally, we have the mistake that students make is that they alphabetize substituents incorrectly. When you are alphabetizing, go by the actual substituent name. Ignore, die, or try. Now, here is what we mean. Let's say you have two methyl substituents present, and then you have one ethyl substituent present. Ethyl starts with the letter E, while methyl starts with the letter M. When you want to identify the presence of methyl, since it is two, you are going to say dimethyl. And when you want to identify the presence of ethyl, you just say ethyl straight. Now, there are times students make the mistake of saying, okay, since this is dimethyl, it starts with letter D. So D becomes before E. Let's give this one priority. No, you are to ignore this prefix, di, tri, tetra, whatever it is. You are to go for the main name, which is methyl. Methyl starts with letter M, while ethyl starts with the letter E. So you're going to give priority to ethyl instead of methyl. I'm sure you understood what I just said. Alright, so here are some practice questions for you. In closing, I want you to name this compound that we have on the screen right now. I want you to name it for me and then drop the names of the compounds in the comment section below where I'll be waiting to receive them. Here is another practice question I want you to try out for me. So here is a hint that I left alongside this question. This is a compound that has an alcohol functional group and it has 4 carbon atoms. So I want you to name it for me and then let me know what your answer is in the comment section below. And then finally, here is the last question for you to deal with. Which group has a higher priority? Is it the aldehyde or the alcohol? If you have an organic compound that contains an aldehyde, CHO, and then you have alcohol inside the same compound, which one are you going to assign priority to? Is it going to be the alcohol or is it going to be the aldehyde? Let me know in the comment section below. I'll be waiting to receive your answers. If you stuck around till the end of this video, I want to say a very big thank you. It's been a very lengthy watch up until this point, and I want to say thank you for engaging with the stuff that I put out on consistent basis. Up next, we're going to be looking at the concept of practicing some questions. We're going to just be practicing some questions to solidify and consolidate our comprehension of this topic that we've been treating thus far, so that we can master the concept. So up until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry. I'd like you to please subscribe if you haven't, like this video, and share to as many as you can, and turn on the notification bell icon so when more videos like this come out, you'd be the first to be notified. I look forward to coming your way next time, and I will surely see you in the next video where we treat some practice questions.